Page 20, number 5. 1,800 meters of fencing is available to fence 6 identical pens, as shown in this diagram. Explain why 9x plus 8y equals 1,800. Show that the area of each pen is given by this complicated function here. If the area enclosed is to be maximized, what are the dimensions of each pen? Okay, so this is similar to the one we saw before, where we want to write 2 equations. One of the equations would be related to the total amount of fencing, and the other equation would be related to the area. Okay, so let's write an equation about the length of the fence available and how much we used. So the amount of fencing we have is 1,800, right? And then they've already defined for us that this short length is called x, and the long lengths are called y. And we can see exactly how many x's and how many y's there are in this drawing, right? Looks like there are 9 x's, and let's see, 1, 2, 3, 4, 5, 6, 7, 8 y's, right? So actually, if we write this equation where we have 9 x's and 8 y's, we can set that equal to 1,800, right? Because that's the total amount of fencing available. So basically, if we're going to explain why, we're going to say, oh, because there are 8 short segments, or there's 8 long segments, and there are 9 short segments. Okay, that's why. What about B? It says, show that the area of each pen is given by that complicated function there. Okay, so let's do this. Let's try to figure out the area of the total pen. So it would be 2y times 3x, right? It would be the length times the width. So the area is equal to 3x times 2y, which is equal to 6xy. And there are 6 pens here, right? So actually, what we're looking for, the area of like one pen is going to be 1/6 of this. So actually, it's this divided by 6, which would just be xy. Okay, and so now we need to say, okay, well, they want an expression with no y's in it. Okay, so how do we get rid of the y's? Well, we're going to take the equation that we got in part A, and we're going to find an expression with y equals blah, blah, blah with x in it, and then we're going to substitute it in and get rid of the y. Okay, so let's do that. Let's see, we're going to start with 1,800 equals 9x plus 8y. First, we're going to subtract 9y from both sides. That will give us 8y, or 9x from both sides, and we're going to get 1,800 minus 9x, right? Then we're going to divide both sides by 8, and we're going to get y equals 1,800 divided by 8 minus 9 divided by 8x. And then we can put that in for y, like we were planning to do. And then we will have an expression x times 1,800 divided by 8, which, let's do that on the calculator. 1,800 divided by 8 gives me 225 minus 9/8 x, and that's equal to negative 9/8 x squared plus 225 x, and that's exactly what we were trying to get. So that worked. Okay. C. If the area enclosed is to be maximized, what are the dimensions of each pen? So now what we just need to do is find we're going to graph this area equation here and then see where the maximum point is. So we're going to put here the equation we have here, negative 9/8 x squared plus 225x. Then we're going to graph it. Okay, we don't see the vertex, so let's try zoom fit. I think the vertex is still going off the screen. So let's do window, and we're going to put an x max of like, instead of 100, we're going to put 500. Then graph. There we go. There's the vertex. So if we want to find that vertex, we could do second, calc, maximum. Go to the left a little bit. Hit enter. Go to the right a little bit. Hit enter. Guess. So the maximum, x equals 100. And it looks like it says y equals 11,250, but be careful because this y is not the y that we have here. It's not small y, it's a big y. And the y in this case is actually whatever this function equals, which remember is the area of one of the pens, right? So x equals 100, and the area is equal to 11250. What is the y dimension equal to? Well, we can find the y dimension by using one of these equations here, this equation here, right? Which could also be expressed as this, right? So what if we put in 100 there and see what that equals to? We would have 1,800 divided by 8 minus 900 divided by 8, which would be 900 divided by 8. So actually the value for y is 900 divided by 8, which is 112.5. So the dimensions of the pen would be 100 and 112.5, and the area of the pen would be 11,250. Moving on to number 7. The graphs of y equals x squared minus 3x and y equals 2x minus x squared are illustrated without using technology. Show that the graphs meet where x equals 0 and x equals 2.5. And find the maximum vertical separation between the curves for x between 0 and 2.5. Okay, so we have two quadratics. Let's say we have the red quadratic, and then we have the blue quadratic, which is that one. And then we're trying to find where they intersect, first of all. So to find their intersection points, we've already done this before with quadratics and lines. In this case, we're doing it with two quadratics. We do it the same way. We set the y's equal to each other. So we got the red quadratic equal to the blue quadratic. And then we just move everything to the left side, and we make a purple quadratic, which is going to be 2x squared minus 5x. And then the right side is going to be equal to 0. And then we could factor. We factor, we get that. And so the solutions to this would be, one would be x equals 0, the other one would be 2x minus 5 equals 0, which means 2x equals positive 5, which is equal to x equals 5 halves. So these are the two x values which mark these two intersection points, and so we just proved that. Okay, and then it says find the maximum vertical separation between the curves for this region here. So the vertical separation can be written as it could be written as blue minus red, right? So the vertical separation is equal to blue, which is 2x minus x squared, minus red, which is x squared minus 3x. And then to combine these in one, we would have, this would be negative x squared plus 3x, so negative 2x squared, 2x plus 5x. So that's the vertical separation. And the question is, when is the vertical separation maximized? So actually this is a parabola, as you can see. So the vertical separation, when is it maximized? It's maximized at the vertex. So again, all we need to do is find the vertex of this quadratic. The vertex can be found at negative b over 2a. So that would be negative 5 over 2 times negative 2, which is negative 4, which is equal to 1.25, positive 1.25. Okay. And so the maximum vertical separation would be found by plugging in 1.25 into the vertical separation equation. So the vertical separation maximum will be negative 2 times 1.25 squared plus 5 times 1.25, and then we could find that by using the calculator. So I just typed all that in the calculator. I have 2 times 1.25 squared plus 5 times 1.25, and the answer is 3.125.